Alrighty, so we gotta start right now. Yeah. Thank you so much joining today. Yeah, first of all, I don't believe you guys still here, so get out and then enjoy the city. Yeah, it's almost 6 p.m. You got some nice dinner plan right now. Anyway, so once again, yeah, just joking. Yeah, thanks again joining today. So I'm gonna talk a little bit about the event-driven autoscaling for serverless Java application. Just a quick question: who actually hate Kubernetes? No one? Okay, you should get out right now. Okay. Oh, over there. Okay. Yeah, cool. So first of all, my name is Daniel. I'm working for Red Hat, and then I am developer advocate and spend a lot of time to bring more Java workload and Java application into cloud, aka Kubernetes. And also, I'm CNCF ambassador to help you out, like a developer, SRE, or platform engineers, to bring more application into Kubernetes cluster plus ecosystem like a serverless service mesh and GitOps practice, etc. So here's my quick information: Twitter, YouTube channel, and then my GitHub repository. Yeah, feel free to steal whatever you need, and then like put on some any question. I'm more than happy to address after session. All right. So here's the auto-scaling architecture on the Kubernetes. And then you probably know one of the beauty of Kubernetes is to orchestrate your application, aka pod, and then like whenever you have like a network traffic or incoming stuff, the Kubernetes decide when your applications get out in based on like a resources like a CPU and memory, based on the Horizontal Pod Autoscaler, aka HPA. So here's some architecture example. We have a bunch of microservice application running on pod on the Kubernetes, like inventory, catalog, auto item, or some of stuff, whatever you will call like a business application. You can actually create each HPA along with your microservices on top of the Kubernetes, and then it automatically scale out and in based on like incoming traffic. However, that's not the end on reality, because when you design or implement event-driven application architecture, you need to consider about external services. For example, like event-driven, like a Kafka server at backend services or managed service, or whatever they call, and then like a metric data from Prometheus, and even sometimes the public cloud provider provide like a bunch of the metric information and infrastructure, like a AWS cloud formation, and then Azure like a monitor and that kind of stuff. You need to figure it out. So event-driven or event storming, not just only like a RESTful API, it's more like event storming, and then there are tons of metrics or tons of OpenTelemetry or metric data is coming from in anywhere from external services and not inside the Kubernetes. So how to design your auto-scaling infrastructure? Maybe here's a known practice or example. As you can see on the bottom side, and then you can exactly same portfolio, but the upper hand side. So you can define and then implement Kubernetes custom metrics. And then you can create like a metric adapter for your external services. For example, for the AWS CloudWatch and then Prometheus, unfortunately, there's no Apache Kafka metric adapter, so you cannot directly adapting and then enable the Apache Kafka stuff. So that's why you have to collect the data from Apache Kafka into Prometheus, and then Prometheus can be enabled into your Kubernetes metric the infrastructure. So the problem is here. So you can only enable one adapter at once, but in reality, it's totally not optimized in this architecture, because so for example, my inventory actually needed to scale out based on like a CloudWatch for the external services. However, my payment service actually should be scaled out based on the Apache Kafka incoming like event-driven stuff. So how to handle that kind of stuff? So that's why KEDA actually design and then develop. So KEDA is just literally Kubernetes event-driven auto-scaling project. It's pretty simple. And then it invented by Red Hat and Microsoft and back in there. And then it project already donated CNCF and already approved as the incubation project. So the good thing is KEDA actually not intervene your existing Kubernetes resources. You just need to deploy as a just traditional way, deploy application using deployment and the jobs and the stable set. And then KEDA actually monitor your the normal and then fundamental resources on top of the Kubernetes, and then decide when the application actually scale up and down, like a 0 to 1 and a 1 to 0. And the more important thing is KEDA actually trigger existing HEPA as well to scale more than one. So in the end, your application scale out like a 10 or even 10,000 pod, but based on your event-driven metrics. You can install multiple ways KEDA on your Kubernetes cluster, like the operator and Helm chart, or even the other stuff as well. So now we can redesign the event-driven architecture and then like this infrastructure based on KEDA. And the wonderful good thing is KEDA actually provide the own scaled object or scaled job, which allows you define targeting Kubernetes resources and then the source, event source, and that kind of stuff as well. The beauty of the KEDA actually here, as you can see, you don't need to create the HEPA for each application. However, you just create the scale object, and then you can map to external service for any use cases. And then you can actually scale out the each Microsoft application on a pod based on that metrics. Not single adapter. It's a multiple metrics matching into the application use cases. So here's a quick architecture how the KEDA works based on the KEDA own, like the controller and the scalar object. I just mentioned earlier, like scaled object and job, and also it's trigger existing HEPA resources. It fundamentally scale 1 to 0 and 0 to 1. That's it. However, you can actually trigger to HEPA. In some case, you need to scale out more, like a 10,000, something like that. It's pretty simple. So quick example, here's how to specify your YAML file to set it up KEDA. But what about the serverless? So the KEDA, as I mentioned earlier, is just normal pod. So pod is just not serverless application, like not Amazon Lambda, not Google function or Azure function. But you wanted to use like a serverless capability with the event-driven auto-scaling. So maybe you thinking about Knative project. So Knative is built on Kubernetes. It allows developer or even cross-admin manage your application as a serverless behavior. So once you deploy your application as a Knative service resources, it will be scaled up and down based on demand. And then just like Amazon Lambda behavior. But here's a big difference things between KEDA and Knative. So KEDA is not going to intervene existing Kubernetes resources. Just you can monitor existing deployed Kubernetes resources. However, you need to rewrite your Kubernetes resources based on Knative services specification. So that's the one big different thing. And then there are a few more how to the install way, and then KEDA based on using the autoscaler HEPA on the top of the Kubernetes, but Knative actually own autoscaler, which he called Knative autoscaler. And then there are some deeper model like a pull and push, how to monitor, and then when actually the application scale out in the decision point. So I'm gonna try to showcase the 4 different demo today rather than keep talking the boring stuff. So here is a 4 use cases how to design your auto-scaling architecture on top of the Kubernetes to handle event-driven application. So first of all, let's start like as a beginning standpoint. So application consuming messaging, for example, Apache Kafka, which is just super popular, the event-driven system as a backend services. So here is we're gonna use Apache Kafka, and then I'm gonna deploy application, one of the Java application based on Quarkus, and then using HEPA, and then how to scale out based on HEPA. The one thing is you should be aware that this is not event-driven, but the reason why I want to showcase this use cases because this is a traditional and a very popular use case for auto-scaling architecture. So if you have any chance, stop by the Red Hat booth, you can find this Rockstar sticker on the right-hand side. It's really pretty cool. Okay, so I just stop my sharing, and then first of all, here's my Kubernetes cluster. I think everybody see that. So this is an OpenShift cluster by Red Hat based on Kubernetes race version. And then I already created a bunch of the multiple namespace here. And I here go to like admin console. And then I already installed 3 different operators today. One is KEDA. Let me try to bigger. So one is KEDA. The other is the Red Hat integration, which allows me to use and create the Apache Kafka and topic as well. And then the Red Hat OpenShift Serverless operator is based on Knative. So I just only needed to 3 different operator: Knative, KEDA, and Apache Kafka. That's the thing. And then just change it as developer standpoint. So for the first project, so let me try to go through real quick here. So here's the KEDA namespace. Maybe I'm gonna a little bit bigger. So as you can see, so operator already installed, and the KEDA server, and then operator, and then API server. And then here is the OLM for the automate your life cycle. When you update your KEDA version, it automatically upgrade like over the air, one of the beauty of the operator thing. And then here is the Knative serving, which has its own autoscaler, as you can see, and then a bunch of the required pod already deployed here. And the last thing is the Knative eventing to address your eventing messaging from serverless application. Also, here's one interesting thing here. As you can see, the bottom line here is a Knative and Kafka integration. So Knative eventing actually address your event messaging based on cloud events. So just in case who actually never had heard about what the cloud event buffer. So you can actually implement any types of event messaging, like a JSON format or a binary or even protobuf. So there's no obligation what kind of format you're going to use for event-driven messaging on your application, regardless of the runtime environment, like a Java, Python, Node.js, etc. However, a problem is when you deploy the Polygon runtime on the Kubernetes, and then how to communicate between that runtime, specifically different types of messaging format. So maybe back in there, maybe you got an integration solution to transform that message from here and there. But that is not Kubernetes native way. So that's why Cloud Event Project was born, like provide a standard way to communicate the event streaming messaging. So Knative event basically handle the cloud event message here. So my first namespace, Kafka HPA. So I already deploy and create the Kafka cluster here. As you can see, here's my Kafka cluster. And then here is the another thing is the Zookeeper, but the HA stuff. And then I have 2 projects today here. Yeah, I think it's a little bit dark, but this is my favorite Quarkus theme. So two projects. So one is Quarkus, just like for HPA and the KEDA. The other one is more like a Kubernetes stuff. I'm gonna go through the next project as well. So let me take a look at the first project. So we just released last night a new Quarkus version, like a 2.13.2. The Quarkus community, we actually release almost every single 2 weeks. And then it's really super fast evolving. So if you take the new version, like a 220, you got some new version in next 2 weeks. Really cool, isn't it? More challenging stuff. Okay. So this is a so simple application. I'm going to use the reactive stuff here and messaging to Kafka here. And then the sample application is pretty simple, just like a hello world, but a little bit just the print out and the messaging from Kafka topic. Here is maybe interesting part, someone who really have some challenge or concern about Spring Reactive application development. So if you have some experience to develop Spring Reactive, it's totally different anymore than just Spring Boot. And then in order to integrate the backend Kafka services with Spring application for reactive programming, you need to rewrite all application based on Spring Reactive. And also you need to add like a Spring integration. Well, also you need to maybe sometimes you can add a Spring Cloud, like a Spring function, etc. It's maybe totally pain in the ass to figure it out what dependency and what library I need to add on my project. And then also it's not easy to make maybe optimization for the reactive programming. And also, the more important thing is that you need to rewrite your existing Java classes and method. So Quarkus actually built on and born based on reactive, the engine. But good thing is you can still develop imperative application like a process, HTTP, or like a TLS termination processing using like a RESTful API. And then you can just change the relevant annotation on top of the method level, and then your method in the class just handled by reactive way. So here's a quick example. I just need to just add the just normal Java method on top of the incoming with my topping name, Kafka topping name, and then Quarkus handle this Java method as a reactive programming. And then back to my cluster, you can see, and then my keeper here, and the Kafka thing. So this is my Kafka, and the same name is my topic. And then go to application. It's a pretty simple computation here. I already set it up like this is based on small right Kafka, and then what is my topic name, like, and the group name ID, and where is my bootstrap. So in this case, is the bootstrap name is actually Kubernetes service name. If you want to access my external Kafka cluster, like on top of the Azure Cloud or Amazon or even on-prem, you can just specify like APK URL or even IP address in there. So that's pretty simple. And then let's try to, I'm going to deploy this application first, and then I'm going to open my terminal window. And then there are several ways to deploy Quarkus application directly to Kubernetes. Once you edited Kubernetes extension or OpenShift extension, it automatically packaging your application as a jar or a native executable, and then containerize it, and then make a container image, and then push it into any container registry if you want, and then in the end, and then finally, Kubernetes pull down that image any available worker node. But in developer standpoint, you just need to run the single command line like a Maven or a Gradle. So today I'm going to use a Quarkus CLI. It's one of my favorite things because I don't need to remember all parameter or argument when I run Gradle or Maven. It's just super simple. So I'm going to try to run the Quarkus build, and I'm going to skip unit test. Sorry for that, Eric. He really super important thing about test-driven development, but yeah, no offense, by the way. So it takes maybe a few seconds or takes a minute based on how complicated your application implement. So it is pretty simple, as you can see. And So first of all, I'm going to packaging this application like a jar running on JVM, like a Quarkus say fast jar, not saying like a thin jar or Uber or a fat jar. Just a really fast jar is faster than just traditional Uber and the legacy jar because Quarkus actually override the Java class loader. So we already figured out where the class path is, which means the Quarkus application doesn't need to scan all the class paths. It takes a little bit more time. So I should pray to demo God with the finger crossed because the Wi-Fi internet pretty bad here. Okay. So yeah, let's take some moment. So once I deploy this application, and then the first step, it will just like the just packaging application like a jar file, fast jar, and then containerize it based on Docker file. You can actually use in the local Docker file. So when you actually generate project, there are Docker file automatically generated for developers. So you don't need to write down your own Docker file. It's automatically generated like a Docker file for JVM or Docker file native executable, and even a legacy jar. Sometimes your environment only allows to run legacy jar because the fast jar on the Quarkus side is a little bit different target directory path because the running jar file is not existing, doesn't exist in the root path on the target directory. So that's the thing, and then you can actually override this Docker file if you need. And then back to here, we just deployed that. And then let's go back to our web console here. So now we have the Quarkus application here, which is cool. And then just check the view logs. And then I have the new version, which he released last night, and then we're running on JVM. And then it takes a 4.5 seconds startup with the bunch of the capability, like a Kubernetes, and then Kafka integration, and the reactive stuff, something like that. Okay, let's go back to topology. Here is the interesting part. As you can see, I can actually manually up and down my number of pods, which is not auto-scaling. So in order to make it this my application make auto-scaling, I'm going to use one single command line here. Auto-scale my deployment, min-max 110, and then I would say the CPU percentage is 75%, just like a reality situation. So that means when I got some network traffic into this pod, and then the CPU realization based on HPA reach out to 75%, it start auto-scaling. Okay, let's go back to terminal window. Now I can see the auto-scaling is a pod. And then the one interesting part, actually the Kafka topic server actually include usable the performance test in bash script here, like a Kafka producer performance test script. I just call that performance test bash script as a Kubernetes job, and then I will create like a 1 million dummy event messaging, and then that messaging generated every single second, and the parallel 5 pod here. So I just run this YAML file. You can actually using kubectl, like a kubectl apply, and then I'm gonna try to use like a GUI mode here. So open the import the YAML file, just paste it and create it back to the topology view. Now you can see. So here is a 5 pod just creating image. And then when you click on the view logs inside the pod, you can see the dummy message just recorded, created, and sending to Apache Kafka. And then in the end, the application will consume that messaging from Kafka because we already said the same name, my topic, which is Kafka name, topic name. So when you click on the actual application policy, you can see it's a keep processing, digesting your messaging coming from Kafka topic. And then when you go back to dashboard, and then here's auto scaling. Now we can see still 75% is target to start your auto scaling. However, the current is 0 because it takes some time measure the CPU or even memory utilization based on HPA. that's what I want to say. The HEPA is not good enough for your auto-scaling for event-driven application. So let's move on for the next architecture for designing. So give us a moment because it takes some time to auto-scaling. So back to my slide deck, and I'm gonna change the presentation. So your answer is not enough for the first use case. So what is the solution? Okay, so I'm gonna give you another tips for redesign your architecture. So here we're gonna add KEDA because KEDA is really good for event-driven auto-scaling based on Kubernetes. So here to change and redesign your auto-scaling architecture for event-driven application, but not serverless. So here we go. So your application here, and then KEDA actually just correct your metric directly from Kafka topic. And then in the meantime, at the same time, the application keep consuming messaging from Kafka topic. And then in some point, the KEDA actually trigger scale out the existing the deployment from the 0 to 1, 1 to 0, something like that. And then in the end, we're going to set up the HEPA triggering as well. Okay, so let's go back to here. And then still, you can see the one part because it takes some time. So this is a big problem. So I need to scale out immediately when I got the tons of the messaging from Kafka topic. But this default architecture cannot address that needs. Even if my job is already completed, however, my pod now just started a scale out like a 8. In the end, start like a scale out to 10. Okay, go on next namespace. So here's the same setup, the Kafka topic, and then Zookeeper is set up, but no application at this moment. Okay, so my deployment, I'm gonna just push the packaging, the container image into my external container registry like a KEDA IO in advance because I want to showcase there are several different ways to deploy application. So as you can see, so this deployment specification, the name Quarkus EDA demo, this is a super important thing because we're going to report the same name in the KEDA scale object. And then here is the environment variable, which Kafka topic I'm going to connect. And then here is the image from my KEDA IO image registry. So let's try to deploy the application one more time for deployment. And then I'm going to need to create the KEDA scale object here. Just like I said, the scale target reference is the same name of my deployment, like a Quarkus-EDA-demo. And then also, where is the triggering to decide the scale out and in, which is a Kafka topic here. So I just copy, and then here's my Quarkus application. And then you can see detail, and then you can actually scale in and out manually, not auto scaling stuff yet. So create a new one, scale object, and then you can see it's a change in the auto scaling feature right now based on KEDA. And then you can see HEPA automatic create based on the scale object based on KEDA. So now I'm going to back to and run the same performance load testing here. Try to create that job. It's the same thing, just generated 1 million event message from Kafka topic, and then the application will consuming from them. So when you go to the Quarkus application, now you can see it's already start consuming data and digesting, processing, etc. And when you go back to topology view, and then you can see it's already scaled out, just started. But the purple use case 1, first demo, it takes some time, like 3 minutes to scale out based on HEPA. But the KEDA also figured out, okay, it's the right time to use scale out. In the end, it gets scaled down to 0, if there are any more network traffic. So let's leave it some time, and as you can see, it's automatically scaled out to 10, and just take some. It took like a 10 seconds, something like that. And then back to the HPA project, and then my job is done. And then I still, the 10 pod, because it's still processing the 1 million job, it takes some time. And then it also a little bit more longer time to scale in because like a more like a monitor, still the live session was still some of the request processing. So it should take some more longer rather than scale out. Okay, so this is a two different design. So now our question is, this is not serverless for event-driven. The reason why I'm going to keep focusing on serverless with the event-driven, because serverless always tied to event-driven. So who actually trigger to start up your serverless application, regardless of Kubernetes or Amazon or whatever you call that? It's event. So event should be trigger your serverless architecture or serverless application or platform, anything. And then let me go back to my project here. So I open another project. It's more like a Knative. So just to keep summarized and then showcase the next design, because still we are still hungry, and this is not enough to handling serverless. Even if KEDA is awesome, but this is not a serverless event-driven. So this is event-driven for serverless app. But I'm going to show what is some limitation here. So Knative actually just impact your application directly. That's why the Knative is a pushy model rather than pull versus KEDA. And then the Kafka is the Knative event, as I already mentioned, is some kind of Kafka source. So Knative eventing actually allows created like a bunch of the Kafka resources like Kafka source and Kafka sync and channel broker. So Kafka source aims to consuming some data from resources like a Kafka topic and send that message into Kafka sync. In this case, this sync is application directly. And then let's try to go back to the demo environment. So I'm going to switch it to another namespace here. The Kafka Knative is so you can see the same setup of the Kafka thing. And then back to my project. This is a new project here. So one should be different thing is a little bit different here is I actually rewrite my application previously like an application scope be now a singleton, and then like I try to handle cloud event, even if there's no specific cloud event like a processing method, but you should be aware, and then you should need to more like a change or rewrite your method level, like Java classes, something like that, or address your cloud event messaging. And then I also added the same the dependency here, Quarkus stuff. And then here is the one interesting part for you're gonna specify like a image group, which is the same name of your Kubernetes namespace. And then also you can specify which image registry you're gonna push that local container image when you build. And then here is the one of the handy stuff in the Quarkus. You can specify 3 different type of deployment target. One is Kubernetes, the other one is OpenShift, and then last thing is Knative. This one single line make your application as serverless, like Knative services. And behind the scene, it automatically generate like a Kubernetes resource file, like a YAML and JSON. Let me show you a little bit later. So I'm going to change the project, right project, like Kafka and Knative. And also, I needed to change the project. Here we go. And then I'm going to deploy the application once again. So this is almost same thing, but one different thing is when you go back to application or your local file system, and then once this complete the build application, it automatically creates like a Kubernetes directory under the target. And then there are a bunch of the JSON and YAML to deploy Knative. However, the previous project and go to target directory, you can see like OpenShift YAML because it's not Knative, it's just normal project, normal pod. And back to here. Take a look at the Knative YAML file. This is the reason why you need to redeploy existing application. You have already running application. The thing is, I need to change this application as serverless. How do you do that? So, using Knative on top of the Kubernetes, you need to rewrite the specification here. But as a developer standpoint, you don't need to worry about how to do that, and you don't need to run about the Kubernetes API or manifest, etc. Because Quarkus actually generates automatically for developers. And then back to the terminal, yeah, it's still some kind of download image like OpenJDK 11 or OpenJDK 17, as long as you set it up your local Java home, like a JDK 17, something like that. And then packaging application is almost same thing in the containerized application. And the pushing into container registry, I can set it up like a Docker Hub or Quay.io or Google Container Registry. But in this case, OpenShift cluster actually integrate container registry inside OpenShift cluster. That's why I'm just using that kind of stuff. So one good thing is I just only use one single command line, and behind the scene, there are happening multiple steps, packaging app, and then create the Kubernetes YAML file, and then containerized app. I'm not going to use a Docker CLI, but it already containerized it and then push it into container registry, and then in the end, some kind of running the kubectl to run and create my Kubernetes resources. Okay, here's my application, and then got to view logs. You can see the same version, and then running on JVM, and then a bunch of the my capability here. Exactly same application. And then the default configuration scaled down to 0 on the Knative, which is 30 seconds, which means that if I don't invoke this application like a RESTful API or the Kafka sourcing, this application will be scaled down to 0, just like Amazon Lambda behavior. So let's give us a moment. Maybe in the meantime, I'm gonna just change the label, make this pod a little bit fancy here, because a lot of time you need to deploy many different application runtime or the same namespace in same namespace to Kubernetes. So this is pretty easy to find out. This is based on Java or Quarkus, Spring Boot, or Node.js, Python. As you can see, the application pod is scaled down to 0, just like a no blue circle right now. And then I need to add the Kafka source in this case. So here we go. I just define the Kafka source here, which is the Kafka source, and then the service name, which is the same thing. Here's the Quarkus ADA Knative service, just like a service name, and then the Bootstrap server in the same namespace, Kafka server. So once I created this Kafka source, it's attaching my application. You can see the Kafka source here, and then I'm going to do the same thing, just kick it off the performance job here at the same time, and then okay, here we go. So it's the same thing, and then you can see the job just created and expanded the Fiber pod, and then it will create some dummy record every single time, every single second for the next 2 and 3 minutes until it created 1 million. You can see the application automatically scale up like Amazon Lambda, and then the view logs. So one single pod keep consuming and processing your thousands of the Apache Kafka event-driven messaging. And then the problem is, even after maybe 10 minutes later, it's still one pod based on Knative. It's not going to scale out like a 10 or 1,000, just like a KEDA. Maybe there's some limitation when you're using even event-driven, like a Kafka sourcing and Kafka topic with your serverless or Knative. And then let's go back to HPA project and what happened in there. So the application scaled down to 1, just like a default, like a minimum 1 and max 10. And then you go back to KEDA project, you can see it's scaled down to 0 because the KEDA only manages like a 0 to 1, 1 to 0. If you already trigger HPA, 0 to 1 and scale out to 1 to like whatever you need based on HPA. So let's keep just give us some more one into Kafka Knative project. And then as you can see, the pod not gonna scale out more than 1. So now I'm gonna go back to my slide deck, and this is the last part and list. So how to handle serverless autoscaling with event-driven behavior. So that's the big reason to integrate the KEDA and Knative. So some people ask me, hey Dan, so KEDA is something like a compatible thing versus Knative because the two projects actually provide the similar benefit and the features to autoscaling on top of the Kubernetes and the event-driven stuff. So that's why some companies, some architects just choose KEDA versus Knative. And the other way, choose the opposite thing. So this is actually the beauty of open source community. Just like another example, there are tracing project like open tracing and open sensors. In the end, they actually combine under the open telemetry project. So it's a very similar thing. So KEDA, Knative can be integrated. And then KEDA actually manages auto scaling the infrastructure, which is a Knative eventing. And then the Knative only focus on the serverless application. So you can see a little bit complicated redesign, but this is the end goal of this at this moment. So now, from now on, the KEDA keep monitoring and scrape the metric data from Kafka directly, and then at some point, KEDA will trigger to scale out the Knative event infrastructure, which is a Kafka source, and then Kafka source keep sending the Knative services, and then it will automatically scale out the application itself like a serverless app. So going to the project, and then you can see still one pod. Let's give it some moment. So here's my last namespace here. Okay, so back to the project, and then let's try to change it a little bit. So this is the namespace name. So I'm going to change the namespace name from KEDA, Kafka Knative, and then Kafka-KEDA and the Knative. And also, here is one interesting thing. So previously, I have to create a scale object for enable KEDA stuff manually using the YAML file and then using like a kubectl or UI stuff. However, the Quarkus actually provide annotation features. As you can see, key and values in your configuration file, like a YAML or a property file, you can set up the Knative and the KEDA stuff. And it automatically enable that kind of thing. And also, here is Kafka source. Also, not here, the Kafka Knative services and the Kafka. So, okay, here we go. The Kafka source. And then here there are some annotation enable KEDA for Kafka source, just like I showed in that the new designed architecture. Okay, and just save application property, and back to the terminal. Let's change it to my project in a live space, and I'm gonna try to deploy my application one more time, and then hopefully this is the last deployment today. So when I deploy this application, and then it will deploy into new namespace, and then I'm going to enable the Kafka source along with the KEDA. And then I'm going to just hit the performance test once again, just like I did 3 times. And then we're going to take a look at that, how the Knative service as a serverless application scale out much faster than the other use cases, and also the Kafka stores the scale thing as well. So let's go back to the window here and take a look at the HPA once again. So it's a 1 pod and the scale down to 0. And then I'm pretty sure KEDA is just done, and then job done is scaled down to 0. So it's pretty much optimization rather than just HPA, because you don't need to spend unnecessary resources with the KEDA, just like event-driven. And then here's the Knative. Yeah, we're still working on it. The reason why I have only 1 pod, which means the 1 pod needed to process million messaging rather than like a 10 pod. So the last namespace here. So it's still deploying. It's almost done. It's a packaging application based on Docker file. And then last thing, I just push that. All right, let's go back to here. So hopefully it's coming up soon without error. Finger crossed. Double time. Okay, now we got it here. And then back to the application. And then let's try to the Kafka Knative source. And then just create a new one. It automatically attaches to the application, just like the Knative and Kafka stuff. And then let's try to hit the performance test once again here, my job here. So let's give it some moment, this application scale down to 0. And then I'm gonna just hit the job, and then looking at how fast is the scale up and out instantly. So that's the last part of this demo. So in the meantime, let's try to add like a label thing here, just for fun once again. Okay, so in the meantime, it's scaled down to 0. So let's try to create the job here. Back to here. And then the job just started. And now is creating the 5 pod. Just give it a moment. And then once it pull down, as you can see, your pod application just started. In the meantime, it automatically scale out to 10. So you don't need to wait for like maybe 1 minute, 2 minutes, or pretty much longer than like the Knative or the other HPA stuff. And then so this is a serverless application scale from down to 0, as well as just scale out based on event driven. So super fast to scale out based on the event streaming from the Kafka topic. So that's it. That's the I want to showcase today about this for the redesign or the scaling for specifically the serverless Java application. Let's take a look at that. I'll go back to Knative stuff. What happened in there? Yeah, still in there. Yeah, so it takes some time to finish that. Okay, let's try to summarize today's session. So you can also use another more the sourcing, the event-driven plus Knative and KEDA integration. You can use the AWS SQS source and the Redis streaming and the RabbitMQ broker as well. Not only the Kafka source. Just define the relevant annotation on your YAML file, or you can edit this annotation on your Quarkus application. It's a quick summary today. So KEDA is just Kubernetes native, just event-driven autoscaling, pretty simple, that simple. And then big different thing is pull and push model. And then you don't need to change any existing Kubernetes resources because KEDA only triggered existing resources. But however, the Knative, you need to rewrite your Knative services. And then most important thing is you can actually combine the benefit from Knative and KEDA at the same time. So I already made a video recording on top of this kind of stuff. Here's my building URL and my QR code. Yeah, feel free visit my YouTube channel and then just take a look at it. I already pushed more than 200 video at this moment. That's it. That's I want to show today. So I have 1 minute left. So just check it out. Back to my application. Okay, it will scale down to 0, like more flexible rather than the other stuff. So when you go to KEDA and Knative integration, as you can see, it already scaled down to 5. So pretty fast and pretty dynamic and flexible based on your event-driven storming. Thanks again, and thanks for joining, and hope you enjoy the rest of the conference. Thank you.